Hi Algebra 2! In this video we're going to keep working with logarithms and look at some new properties that we're going to use. Here we go. Remember that with exponents, if you have the same base, you get to multiply the exponents. So for example, if you have 3 to the 4th times 3 to the 5th, you could add those exponents and it would be the same thing as 3 to the 9th. We're going to see something very similar with logarithms. I'm going to start with this piece right here, and if we're going to be adding logarithms that have the same base, we get to multiply the number that we're taking the logarithm of. So for example, in this log base 3 of 10 plus log base 3 of 100, you would multiply your 10 times 100 and it would be the same thing as log base 3 of 1000. So for example, in our first problem right here, we have log base 6 of 4 plus log base 6 of 9, and I could multiply 4 times 9 and just write it as log base 6 of 4 times 9, which would be log base 6 of 36. So there we rewrite it as a single logarithm. Our instructions also say to simplify here. So here I'm thinking 6 to what power equals 36, and that's going to be a power of 2. So that would be that logarithm simplified. As a single logarithm, this one would be log base 5 of 15,625. So I'm thinking 5 to what power gets me 15,625. I might need to do a little trial and error here, but my answer is going to be 6. 5 to the 6th power is 15,625. As a single exponent, this one would be log base 1/3 of 3. And so I'm thinking 1/3 to what power is 3. And my correct answer there is going to be -1. And as a quick reminder, that negative exponent kicks it to the denominator. So if I start with 3 to the -1 power, that's going to be 1 over 3 to the first power. It kicks it to the denominator and the exponent becomes negative. And this would be the same thing as 1/3. We're going to see similar processes here with division. When we divide with exponents, we subtract the exponents. And so if we see logarithms that are being subtracted like this, we can rewrite them as division or vice versa. Our first problem up here, to simplify, we see that we are subtracting, so I'm going to rewrite this with division. Log base 5 of 100 divided by 4, and I'm going to simplify that into log base 5 of 25, and then I'm thinking 5 to what power equals 25, and my correct answer there is going to be 2. So this is writing it as a single logarithm, and then this right here is simplifying it. In the second one, this is writing it as a single logarithm. And then I'm thinking 7 to what power equals 7, so that exponent needs to be 1. So building off of the property we just saw when we were multiplying logarithms, we're going to now see what we can do with some exponents. So if we have something like log of 10 to the 3rd power, I could rewrite that as log of 10 times 10 times 10, which we just saw we can rewrite as addition when it's being multiplied, log 10 plus log 10 plus log 10. So really what's happening is we're taking 3 of those. 3 log 10s, or 3 times log 10. So our rule over here is basically seeing that we take that exponent and we put it out front and end up multiplying. So this is the same as that. Starting with our first example right here, we're going to take our exponent and put it out front. So it's going to be 6 times log base 2 of 32. And then I'm going to simplify. So I'm looking at this part right here, and I'm thinking 2 to what power is 32, and if I do a little trial and error, I'll see that 2 to the 5th power is 32. So coming back over here, I have 6 times, all of this we just saw was 5, and so to simplify, I end up with an answer of 30. In our next example here, I'm going to take my exponent and put it out front, so I have 20 times log base 8 of 4, and I'm looking at just the logarithm part and thinking 8 to what power gets me 4. Now this seems like a weird one, and I might initially be thinking that it would be 8 to the 1/2 power, but what that really means is the square root of 8. And so I'm thinking maybe 8 to the 1/3 power, which is the cubed root of 8. So what number times itself 3 times gets me 8, and that's going to be 2. Well, 2 times 2 is 4, so 8 to the 1/3, which is 2, times 8 to the 1/3, which is 2, is going to get me 4. And exponent-wise, I can add those exponents, it will be 8 to the 2/3 power. So that exponent there is going to be 2/3. So coming back over here, I have 20 times, we just saw that this whole thing is going to be 2/3, and 20 times 2/3 is going to be 40/3, and we can just leave it like that. In this next example, remember that if the base isn't written, that means that it's base 10, and so I can take the 4 out front, so I'd have 4 times log base 10 of 10. So when I rewrite it, I get this, and then I'm thinking 10 to what power gets me 10? That's going to be a power of 1. That's what this part equals, so 4 times 1 is 4. Here I rewrote it and got this. 5 to what power gets me 25? That's going to be 2, so this part equals 2, so 2 times 2 is 4. Next we have two inverse properties of logarithms that are handy to use to simplify things. You're just going to use these examples right here to simplify each of these. So the first one we see correlates to this first inverse property we see there. And what happens is that log base 3 of 3 to the 11th power is just going to equal 11. Notice that up here your exponent is what your answer ends up being. In B, it's not quite as obvious what we're going to do with the inverse property, but we can rewrite 81 as 3 to the 4th power. And so now I can use this same inverse property that we saw up here and just write our answer as 4. In our next inverse property right here, if we have a number 2, a logarithm, then our answer just ends up being the number that we're taking the logarithm of right here. So in part C right here, 5 to the exponent of log base 5 of 10 is just going to be 10. Next we have the change of base formula, and this one is really good for when you are going to use a calculator to evaluate your logarithms, because lots of times calculators can only use base 10. So what we're doing with this is we're basically taking a logarithm and we can make it any base we want. That's why this a just kind of appears here, as long as we use division. So log base 32 of 8, I could rewrite as log of 8 divided by log of 32. And now this is going to be something that's easier to put into your calculator because now the base is 10. When you're using Desmos to evaluate these, you're going to be looking under functions and then under miscellaneous right here. And then you're going to use the logarithm button right here. Yes, there is a button here that you can put in any base you want, which is great, but not all calculators have that. So you might want to practice using this change of base formula and the regular logarithm button just to get used to that. Evaluating on the calculator gives you an answer of 0.6. Here I wrote it using the change of base, so now my base here is 10, and then I used the calculator to find out my answer would be 1.5.